Oh, hello. Welcome to this video about types of matter. I think you should really care about atoms. Why? Because they matter. And because all matter is made of atoms, so atoms are matter. They matter. You get what I'm... Okay, yeah. All right, you're with me on this. Excellent. All right, we are talking about types of matter today. And in this video, let's start off with something that you probably have already heard from me, which is, what is matter? Well, matter is anything that has mass. Anything that has mass that we would measure with a scale and come up with a number of grams or something like that. Anything that has mass and takes up space, we call that matter. Okay, that's matter for us. So, simple definition to start off with. And of course, what are atoms? Well, we said matter is made up of atoms. Atoms are the fundamental building blocks of matter. And they can't be broken down by ordinary chemical means. And hopefully if you're watching this video, you've seen me do previous videos about the extraordinary means by which we can split atoms apart or fuse them together, do other things that release tremendous amounts of energy. But in our average everyday chemical reaction, we're not breaking the atom itself apart. We're simply exchanging them, breaking the bonds between them, and then reforming them. And of course, if you haven't seen this before, this is an actual image of an atom taken with something called a quantum microscope. And you can kind of see the nucleus and kind of see this is where the electrons would be. Super weird stuff, actually, because it's not necessarily where the electrons are. It's where they are probably. Anyway, we don't need to get into that. But if you want to, you can look up some quantum stuff on your own. Okay, so why do we know this about matter? Well, we know it because of courtesy of Albert Einstein, actually. So, well before Albert Einstein, there was someone whose last name was Brown and whose first name I forget, because he wasn't as famous as Albert Einstein. But he noticed a phenomenon called Brownian motion. And Brownian motion shows that tiny particles of matter just bounce around randomly. And I can even demonstrate this to you courtesy of the Crazy Russian Hacker. Let's see what Crazy Russian Hacker has to say. Number one priority.
In this experiment, I'm going to demonstrate Brownian motion. Let's check it out. So I got here hot and cold water, and I got here ink. I got it from the pen and mixed it a little bit with water. First, we're going to drop a couple drops of ink in the cold water and then hot water. So just a small drop.
Okay, there it is in cold water.
Spaced together and sinking slowly down into the glass, kind of slowly. Now let's start the same thing in a hot water. Just a small drop. I put 3 drops. Let's see what happens. As you can see in this glass, it's actually kind of sink down really fast. And as you can see, it actually dissolves before it's hitting the bottom of the glass.
Okay, so that's Brownian motion, and that actually should tie back to something that hopefully you remember, which is the kinetic molecular theory, telling us that molecules of substances are always in motion, and that motion, the amount of motion, which we can call kinetic energy, is based simply on its temperature. So higher temperature means faster moving molecules, and that's what happened. The ink molecules got hit by faster moving water molecules because the water molecules had a higher temperature, right? And that's what happened in this hotter glass of water over here. So Einstein, in 1905, was the one who mathematically proved that Brownian motion is a demonstration of atoms being the fundamental building blocks of matter. His math, I would never understand that at all, but tells us a little something about what matter is truly made of. And so since then we have come up with some sort of bigger categories of what matter is, and we can classify it basically in sort of 2 tiers. And the first tier is whether matter is a pure substance or a mixture. Pure substance or a mixture. So pure is a word that gets thrown around a lot, and here's an example. Here's a Dove Pure bar or a container of deodorant, And it's pure because it's free of these four things, and that's just some marketing definition of pure. What we mean by pure when we're classifying matter in science is pure substances have the same composition throughout. So it's just a pile of an identical something. And that something could be either a single element or a compound. But the property of each part is the same. If I had a pile of it right here and I grab some here and I grab some here, the properties are going to be the same no matter where I grab it. So here's an example of a pure substance that happens to be just one element. And that's copper. Copper wire is the most common copper is the most common metal used for wiring in your everyday household wiring and stuff. It conducts electricity very well. That's one of its properties. So copper is just made out of pure copper, which is an element, right? It's simply refined from ores found in the ground, and then you just have copper. And so that's a pure substance that is an element, right? Pure substance, two kinds. This happens to be the kind that is an element. On the other hand, pure substance that is a compound could be, for example, sugar. So pure table sugar is a covalent compound. So here's a pile of it, and here it is in cube form. And it's a covalent compound. It's 12 carbons, 22 hydrogens, and 11 oxygens in the form that is scientifically called sucrose, and that's often, what you find in your candy and stuff, and that's also a pure substance. It's just not made out of one element, it's made out of many elements stuck together in a compound. Okay, and then our other kind of category besides pure substances is mixtures, right? If it's not a pure substance, if it's not all one element or compound, it's a mixture, right? And so mixtures are two or more elements and or compounds that are physically combined, not chemically combined, because then they would become a different substance. They become a new compound, but they're physically combined, right? We just kind of pile them together. And individual parts of mixtures can have different properties and can be distinguished from each other. So, for example, Chex Mix is one of our, probably best known mixtures, right? And you can see in a little picture here, that it's a mixture of things like Chex pieces. There's the light colored Chex and the darker colored Chex, and these sort of pieces of pumpernickel bread maybe, and these, I don't know what they are, like slightly cheesy sticks and pretzel pieces, right? And that's all mixed together, and they have different properties. They taste different, they have different shapes, but they're all mixed together in the same bag. And we have two different kinds of mixtures, and these words may sound new, but they're important because they come up in a lot of contexts in science and otherwise. And so mixtures are either homogeneous. The word root homo means the same. So homogeneous, composition is the same throughout, or heterogeneous. The word root hetero means different. So heterogeneous is a mixture that's not the same throughout, where regions have different properties, right? So essentially with a homogeneous mixture you can see, well, it all looks the same. With a heterogeneous mixture you can say, I can pick out the different parts there. Pause the video if you need more time to take notes, but here is a few examples. Milk is a great example of a homogeneous mixture. And in fact, milk generally says homogenized on it. Homogenized means made into a homogeneous mixture. So you might not know this, but traditionally milk actually would separate. If you just sort of take it from the cow and let it sit there, the cream rises to the top. And you end up with kind of not a very homogeneous mixture. So because that sometimes led to weird stuff, and shoppers don't necessarily like stuff like that, a while ago milk manufacturers figured out how to push milk through specific filters to make it look all the same throughout, so kind of break up a few of the bigger molecules. And so generally speaking, the milk that we drink is homogenized, so made all the same. You can't see the fat separate from the water, separate from the protein, but if you got some raw milk, you probably could. And on the other hand, if you take milk and pour it into your cereal, you then have a heterogeneous mixture. You can see pretty easily the differences, right? So this part of the mixture right here is just some milk, and this part is some dry cereal, and somewhere in here is some soggy cereal, and you can see different textures, different characteristics of the different parts throughout. You can just see that as you look in the mixture. Okay, that's it for this video. Stay tuned for more in the next.